Hello, let me start the afternoon session. I'm Fumihiro Kato again. It gives me a great honor to welcome Professor Manuela Chessa. She is an assistant professor in computer science and at the Department of Informatics, Bioengineering, Robotics, and System Engineering at the University of Genoa, Italy. Her research interests are focused on the development of natural human-machine interface based on virtual, augmented, and mixed reality on the perceptual and cognitive aspects of interaction in VR and AR, on the development of bio-inspired models, and on the study of biological and artificial vision systems. Today, her presentation is entitled this. The stage is yours. Hey, can you hear me?
Okay, can I start?
Okay, please begin your presentation.
Thank you very much for the presentation. Thank you, everybody, for having invited me to talk at this workshop. Today, I will talk about interaction and anti-interaction in extended reality. A few words about me. I come from University of Genoa, and I am in the Perception and Interaction Lab at the Libris department. The focus of our research is the relationship between the study of perception, especially visual perception, and the development of, let me say, better, improved human-computer interfaces, especially the one based on virtual mixed and augmented reality. This can be seen in a loop since the study of our visual, I'm talking about visual since my background is especially on visual perception, but all kinds of perception. So the study of perception in human beings can help us in improving human-computer interfaces. But of course, unfortunately, it is not the topic of today's talk, but also the improved human-computer interfaces could help in a better understanding of human perception. Okay, today you have already seen a similar picture. Few words about the meaning of this picture in this specific talk. The title of this workshop is Extended Reality. We have seen talks and works about augmented reality or virtual reality. It is always difficult to exactly define what is augmented reality with respect to what is virtual reality and so on. Indeed, what we have is a continuum, like the well-known Milgram continuum diagram. So we start from the real environment with all the real stuff, and we can start adding virtual context to this real environment towards a poor virtual environment. And we can say that the poor virtual environments do not exist, since even when we are immersed in virtual reality, we are still in the real world. So what we have is this continuum. And the works that I'm going to present are in between, are among the two extremes, the real and the virtual. Let's talk about interaction. Interaction, again, is a word that contains a lot of different aspects. In this talk, I will especially refer to hand interaction, so what we can do by using our hands. In particular, I will show you some examples about grasping objects and manipulating them. So I will concentrate on what we can do by using our hands in the real world and, of course, in the extended reality. Grasping in the real world is a very complex topic. Here I have put two works that tried to do a classification of all the kind of grasping that we can do in the real world. So just by using our hands, if we would like to grasp objects, we can do it in a lot of different manners. So we are talking about a complex topic. Grasping in robotics, I'm not from the robotic fields, so I'm not a robotician. Grasping in robotics is again a huge topic to be that is currently addressed by a lot of works and a lot of researchers in the world. Grasping in virtual reality is something even different. Here, two examples of two typical application in virtual reality using two different devices, two different paradigms. Here we are in pure virtual reality. The one on the left is freehand interaction by using devices like the leap motion, so two cameras that capture the hands and try to replicate the movements inside virtual reality. The one on the right is a typical interaction by using controllers, so the controllers like the one that are sold together with the HTC Vive or the Oculus Rift. If you look at those images, at those videos, you can see that interaction is different from what we have in the real world. Especially the example on the right. The example on the right is a typical industrial application. It's a training system whose aim is to teach how to assemble, disassemble a specific, in this case, an engine. We can assume that the various parts of the engine are in the real world heavy. So they are pieces that cannot be manipulated and grasped like you are seeing in virtual reality. But in virtual reality, you don't have the tactile feedback, you don't have the weight, you don't have the passive, the haptics. So manipulation is done, like you can see, by closing the finger and by grasping the objects in what we can say is a non-natural manner of manipulating them. Okay. Okay, so this should be fully understood. Moreover, we have two different techniques to manipulate these objects. The one on the left is free hands, so you don't have to have instruments in your hand, whereas the one on the right needs the use of controller. There are a lot of studies. This is one of our studies, but if you look at the literature, you find other similar studies that try to compare the use of controllers with respect to the user of the so-called bare hand interaction, so computer vision-based techniques. In this case, the task was very simple. So we have an immersive virtual reality setup with different 3D shapes. And the task is to grasp all the shape and put them in the correct hole, like the positioning tool game for children. If you look at the completion time, you can see that by using controllers, people are extremely faster. So the time to complete the task with the leap motion, so the computer vision-based technique, took much more time, so 3 times the time of the HTC Vive controller. And it is interesting to understand why. It is interesting to understand why the motivation is quite trivial. So the motivation is that the controllers are more robust in terms of tracking, but people would like to use leap motion and bare hands interaction in order to have to let the hands free and to be able to grasp other objects while immersed in virtual reality. Another comparison, interesting comparison, is if we compare the same action between the real world and the virtual reality. In this example, we have again grasp actions toward these 3D objects. In the top part, you see where people put their finger, in particular the thumb and the index finger, while grasping these. There are 4 objects with 2 different orientations, so 8 configuration. And it is interesting to see that there is not all the people grasp the same objects in the same manner. So there is a variability within different persons. In virtual reality, we don't have this. So people tend to grasp objects, put the fingers always in the same manner. So we lose this variability. And this is interesting, and it is another proof that in virtual reality we are not behaving exactly like in the real world. Another example of the comparison of the different techniques that we have, that we use to act in virtual reality by using another device. So we have again the lip motion, again the controllers, but you know that now you have also seen this morning. We can use the gloves. And in principle, we can think, and when we started doing this example, it was our thought that haptic gloves could be the solution of our problem. So haptic gloves allow us to have bare hands interaction. So we have our hands free, so we don't have to handle the controller. But in the meantime, haptic gloves are tracked in a similar way in terms of tracking system with respect to standard controller. Okay, this is the example. In this case, again, the task is very simple. Here it is done with the controllers, and the task is to take all the pieces of the Iron suite that is disassembled and put the pieces in the right position in order to build the Iron suite. So you can see, of course, this is an accelerated video. And you can see that with the controller, the task is quite easy. Again, we can see with the lip motion. And if you look, now there is the calibration phase. If you look at, again, actions in a few seconds, you can see that, again, grasping is not natural. So the big part of the arm and torso is taken by stitching the hand in this way. But again, it is possible in principle to finish the task. And the last condition is the one with the haptic gloves. Again, we have the interaction. In this case, we can assume that interaction could be more, in a certain sense, more natural. What we have done again is to compute the time to complete the task. And we have also a comparison among the avatar and non-avatar condition, but it is out of the topic of this talk. What you can see is that, again, the fastest condition is the one with controller. And then we have the condition with the gloves. And the last condition is the one that are the gray and the yellow part, the gray and the yellow, the condition with the lip motion. Lip motion, the yellow in the bottom part, in the bottom plot, also is responsible for a high number of errors. Why this? Why this? With controllers, and indeed, I have also taken a look at the poster, and if you look at the literature, controllers are widely used since they provide robust tracking algorithm. So the tracking is very robust. They are not affected by occlusion. The system with the base station or with the camera allow us to put the controller in front of you or behind you, and the controllers are more or less always tracked. And they are not dependent on a hand model. So everybody can handle a controller, and the tracking is not dependent by the size, for example, of the hand. The lip motion is On the contrary, based on computer vision algorithms. Now computer vision algorithms work quite well, but they are affected by illumination problems, noise. They are affected by the fact that we have a limited field of view. And it is the same problem of the HoloLens, for example. If your hands fall out of the field of view, the hands is not tracked anymore. And they are highly dependent on hand models, since upon the computation of the depth, there is some hands model, and not all the hands fit well the model. But they allow bare hands interaction. Bare hands interaction that is allowed also by the use of gloves, but gloves, why gloves are not performing as well as we expected? So they are affected by fitting problems. For example, they are sold with some sizes, small, medium, large, but our hands are not of only 3 sizes, and so you have fitting problems. You have a robust tracking of the palm or of this part of the hands, but there are accelerometers to compute the closure of the hands, and you know that accelerometers could be affected by drifting problems. And again, when grasping the closure of the hands is extremely important, and such drifting could be very annoying. It is why a good solution, an interesting solution is to combine what we have from the virtual reality with what we have in the real world. So it is our vision of extended reality. One possible definition of extended reality is to combine virtual reality with the real world. In this case, to help us in having the so-called passive haptics. And it is why we recently did this experiment. This experiment, if you look on the left, we want to combine interaction in the real world in 2 conditions, and I will explain in a few seconds which are the 2 conditions, with virtual reality. The task in this case is very simple: to take a coffee maker and pour the coffee inside a cup. People is inside virtual reality. So what people see is what is in the left part of this slide. So what people see is here, okay? And people see is a virtual coffee maker, a virtual cup, and a virtual representation of the hand. But in the meantime, people is interacting with real objects. And specifically, we decided to use 2 situations. The 2 situations are, the first one, this one, is the one in which people interact with a simple prism. So something that has more or less the size of a coffee maker, but it is not a coffee maker. And here we interact with a real coffee maker. That is the real counterpart of the virtual one. The opposite, the virtual one is, of course, the virtual model of the real coffee maker. To do our experiment, we compared also with the poor virtual experiment, so interaction in virtual reality without touching anything, so just acting with the lip motion, but there is no passive haptics, and of course the real situation. Okay. You are not seeing it? Oh. Sorry. I lost the connection. Okay. Okay, here you can see a video of the of the different condition. Okay, here in the top part, what the user is seeing, in the bottom part, what the user is actually doing in the prism configuration. And of course, to do this, the real object should be precisely tracked in real time. So the 3D tracking is necessary. Otherwise, you have the mismatch between what we are seeing and what you are doing. Here, there is the typical configuration, and I would like you to look at the position of the hand. Again, the position of the hand and fingers tend to be very close one to each other. And also in this case, the cup is taken, not actually grasping the cup, but very near due to the fact that we are in virtual reality. It is just necessary to be close to the bounding box, and you can catch the object. And here you have, of course, the real situation that is, I guess, quite easy to be understood. What we did is to compare the three situations we decided to look at the smoothness of the movement. In this case, not the errors, since the task is easy to be completed in all the situations. We compared the jerk, and what we have is that, of course, the minimum jerk condition is the real one. So all the participants are without any kind of impairment. And the highest jerk is for the poor virtual condition. Also, by looking at the actions in virtual reality, the action is completed with a trajectory that is not so smooth, since tracking is loosened, and the action is non-natural also if you look at the action. And interesting, the mixed, what we can call mixed, the VR with passive haptic is in between. So we have a smoothness that is more similar to the real one. And interesting, the two conditions, so tracking the prism and tracking the coffee maker, are more or less the same. This is particularly interesting, since it is not necessary to track a complex 3D object, but tracking just a simple object could be enough to provide the haptic sensation, the passive haptics that is missing in the in the typical virtual setup. But again, coming to the hand, again, you can see that hands are not natural in all the conditions. When you track, if you look at the left, when you track the prism, of course, you tend to grasp the prism by putting the hand in the middle of the prism. And it is not so natural, since if you grasp a coffee maker, you should grasp it by handle it in the correct manner, especially if the coffee maker is hot and so on. But in virtual reality, hand configuration is absolutely non-natural. Okay, there are other issues that we should consider in virtual reality. Besides the use of passive haptics, you can put inside the loop models and try to learn how people grasp objects in the real life, and put such constraints in order to allow more natural grasping and avoid non-natural configuration. Okay. This is the end of my talk. I would like to thank all my collaborators. And of course, if you have any question, I'm very happy to answer them.
Thank you for our very interesting presentation. Any questions from the floor, in person or Zoom?
I have a question.
Okay.
I'm wondering, with understanding the similarity and how people manipulate the objects, have you looked at the trajectories that the hands take during the operations?
Yes, what I have presented the jerk is just a way to quantify with just one number the actions, and the trajectories. Indeed, if you look at the trajectories in virtual reality, trajectories are highly dependent on the person. So each person follows a completely different trajectory. and they are very different from what we have in the real world. In this specific case, trajectories in what we call mixed reality, so with the passive haptics, are not so similar, not identical to the real case, but it is due to the fact that the tracking of the 3D object is not perfect. So sometimes tracking is loosened, and when you lost tracking, what people tend to do is to stop for a while, let the system to resume the tracking and start again. So in this case, you have some dissimilarities among trajectories. In poor virtual reality, trajectories are very different. We have also other works in the past, and we started doing this starting from the observation that we follow different trajectories.
Thank you.
You're welcome.
Thank you. Any other question? Can I ask a short question?
Of course.
On the latter presentation, you mentioned the mixed reality passive haptics.
Yes.
And I wonder which one is more important, the texture and the shape. Which one is more important? What do you think?
In this case, which feature is more important in the passive haptics? Okay, in this particular experiment, what we observed is that maybe it's better the first case, so the one with the prism, since the shape is simpler, so the tracking is more robust. Indeed, if you look at the coffee maker, we have to attach a lot of tracker into the coffee makers to make the tracking more robust. So what we observed here is that maybe it's better to track a simple object, so textures are more visible and the tracking is more robust, and map onto the simple object, the prism, map a different object like the coffee maker. So in this situation, it's better this condition with respect to the other condition that is the exact replica. Since the last condition is, at least in this implementation, but I'm aware that the implementation could be improved. In this implementation, the second condition is more difficult. So the tracking is less robust and we have some uncertainties.
Okay, thank you. I understand. Okay, I think that is a time of this this session end. So thanks to the Professor Chessa.